Hello and welcome to today's video. Now today we will be discussing a question that came up in the forums. So an Alibre user wanted to create an alphanumeric serial number that he could then drive with parameters. Now Alibre sadly does not have a text variable that you can assign, but can you create that alphanumeric serial number and drive it with parameters? Well, today we're going to see how. But before you follow along today's video, you should have watched the following: the little triangle that could, parametric multitasking unleashed and Alibre's global parameters, and the Captain Harlock Space Pirate anime. Now we're going to start this by making a part that we're going to use for each digit. Okay, and that part is going to start as a polygon. Now, as we've seen in the little triangle that could, we can make a polygon whose number of sides is driven by a variable by creating the appropriate generated triangle. So we start by making an isosceles triangle, and then we will create a variable here that we're going to call number of characters. Okay, this is going to be a count variable, and for this example, I'm only going to do the numbers, right? I'm only going to create a circle that has numbers on it. So for now, we're going to have 10 different numbers. Okay, so I'm making this variable. So this isosceles triangle is going to have an included angle, which is going to be 360 degrees divided by the number of characters that I want to have. Then I want to give a dimension up here, and I want to make it a driven, because this is going to show me how much room I'm going to have for my character, right? So you need to make sure that this is wide enough for the size of character that you want to use. And you will ask me, well, why don't you dimension that directly? Because it's easier for me if I dimension this and have a round number here. Okay, you will see why later on. But for now, if I make this 35, okay, I get a value here of about 22.75 millimeters. That's enough for the size of character that I want. Now we've made this, you just extrude that mid-plane, and again, the length of this extrusion, or the depth as Alibre calls it, needs to be enough, for you to have the size of characters that you want. I'm going to go for 20 millimeters here. Then you make a circular pattern of this feature. For the number of instances, you give again this variable, and for the center, well, either this edge or the axis, whatever. And now you have this polygon. So if you also wanted letters here, you would have needed enough sides to put in all the letters and numbers. So you need 10 sides for the numbers, and you need 26 sides for the letters. So you need 36 sides. And then you would go in and tweak this number to get roughly the size that you need up here. For reference, for 36 sides, I have calculated that if you do around 120 millimeters here, it should give you around 20 millimeters of length per side. So we've made this polygon. So what do we do with it? Well, we start on a side and we start writing. Okay, so I'm going to have 18 millimeter size letters. So I will start putting those numbers in. And how am I going to make sure that they all locate correctly and on the same area of each face? Well, I'm going to put the letter somewhere up here. I'm going to imprint this as I show in my Engineer Reacts video. And then I'm just going to use the midpoint constraint with 3 points. Make sure this is centered. And then I'm just going to extrude for 3 millimeters. Okay. In fact, I'm going to call this, I'm going to give this a name. I'm going to call it character depth. Now you see that Alibre changed the orientation depending on which side you select. That's not a problem because we've got these pre-selected angles and we can even give a value here. So I'll put in the number 1. And look, I put in the number 1 before I corrected the size here. So how do I correct the size now? Well, I go and make this 18. And then I click in here, and now it's the correct size. And well, how do I make it be the same orientation as 0? Well, this looks nice. Okay, so I'll just put it somewhere up here. I'm imprinting this face. I'm going like so. Now that I look at it, the origin point that Alibre gives you is perfectly reasonable. You don't need to use the midpoint constraint. But anyway, then I will extrude this character depth, and I also am going to select this and copy it. Okay, let's go make number 2. So 18, number 2, I want it like this. I click here. Let's see, does that work? Works perfectly. Extrude, Control V to paste, enter, number 2 is done. And you go on and you create all of the characters that you need to be shown in your serial number, 1 on each face. So now I'm going to make like a cooking show and show you one that I've prepared earlier. Okay, so eventually you come to a situation like this. You have 10 faces and 1 character on each face. So what do you do next? Well, let's create a sketch here. So just for reference, this is my number 0, number 1, 2, 3, 4, 5, and so on. So I'm going to create a circle here, and I'm going to size this circle. This one's going to be D1, which is the 35 millimeters we selected in the very first sketch, twice plus 10, and I found that that is enough for a character height of 3 millimeters. Okay, so I've created this. Then I'm going to create a rectangle, but an angled rectangle, right? And I'm going to make sure that these 2 top points are coincident to the circle. So I'm going to create this distance, which is going to be D1 divided by the cosine A1 of half of A1, okay? A1 is the included angle of the faces of the polygon, the one that we made again in the first sketch. Okay, so we have this. Now I'm going to make this dimension. Now be very careful, this needs to be an aligned dimension, okay? And this is going to be twice D1 multiplied by the tangent of half of that included angle of each face, okay? Now watch what I have achieved with these 2 dimensions. Look, this matches perfectly the first letter, right? This thing can go around and it matches these letters, right? These locations. Okay, so we're getting somewhere. Now I'm going to make a reference line here. So the endpoint is going to be the midpoint of the first face, okay? And then I'm going to create an angle value here, which I am going to call A1. Okay, so look what happens when this value is equal to A1, right? This square goes directly over the number 1. So now I will turn this into a reference figure, and then I will trim off this bit of the circle, and I will extrude, tie tab through all, and I have the number 1. Now here's the real magic. You go into your equation editor, you make another variable and you call it Selector. So that's going to be a count value. Let's say that now it's number 1. So you're going to find that angle you just made. I remember it was A12. Yes, there you go. And you're going to say A12 is A1 times the selector variable. Okay, nothing changed, but watch this. Watch this. Selector. when we make this 0, we get the number 0. That's, oh guys, this is amazing. When we make this a 4, you get the number 4. Isn't this amazing? I find this is magical. I can play with this all day. Make it a 7, you get the number 7. Okay, now that's cool and all, but how do you use it? Well, and we're going to go and create a global parameters file. And we want to create a new one, and we're going to call it automatic alphanumeric input, right? That's going to be the name of my global parameters file. And so I want to create here the same variable that I just made, that selector variable, okay? But I need to create it as many times as the digits of my serial number. Now, I'm going to make a version with 3 digits. If you wanted 12 digits, you would go up to 12. So how do I do it? I'll say digit 1. It's a count type. This is going to be 0. Digit 2, count type, 0, enter. Digit 3, count type, 0, enter. Okay, that's it. I'm going to save this, and I'm good to go. Now, because I created it here, it's already linked. Okay, so if I go into my equation editor, you will see that I've got these variables brought in. Okay, so I will go into 812 now. I'm going to say that this is going to be digit 1. Okay, and now I can delete this variable. I don't need it anymore. Okay, so I wanted 3 digits. How do I get the rest of the digits? And it needs to be done this way for this method to work. You do a save as. Okay, you just change the name to digit 2. Okay, now we're in the digit 2 file. I need to go into the equation editor and change this digit 2. So now it's following the global parameter digit 2. Save again. I change the equation editor. Save as, yep, that's fine. Digit 3, okay. I go into my equation editor. I change this to digit 3, and I save again. So what have I done now? I have created 3 different files, one for each digit of my serial number. And bear in mind that for any serial number input, you will need a set of these digits. So if you have 2 parts that need to have parametric serial numbers, you will need 2 sets of these digits, and you will need 2 different global parameters files. Okay? So let's see how to implement this, shall we? So I'm going to make a new part, and I'm going to call it test plate. And my test plate is going to be a very simple rectangle. Let's say 120 by 50. That should be fine. Let's fully define it. And let's say that this is 20 millimeters thick. Okay. So I want my 3 digits to show here. And every time I go into my global parameters file and I flip a number, I want it to change accordingly. So first of all, I need to link my global parameters file. That's okay. And then I'm going to do a Boolean unite. Okay. And I'm going to bring in digit number 1. So I'm going to right click somewhere here and show reference geometry. There you go. Show the reference geometry. And now it is very important that you assemble this digit in this very particular way so that this works. Okay. So first of all, this is the top plane of this digit, right? Let's open the constraints, the XY plane. So we put it, we assemble it at a height that is convenient for us, right? The height that we want. Okay, actually I want it facing the other way. Okay, no problem, we'll fix that later. Then what you do is you assemble this axis, which is, if you remember, the center of the polygon we made. You assemble it with the face that you want the serial number to show on, but you assemble it at an offset. And that offset is going to be that D1 value that we put in the original file, digit file, and you can even bring that in through a global parameter, make it even easier to put in. And you need to make sure that that distance is behind the surface that you want your digit to be shown. So if I put this offset and this was in front of this surface that I want my digit shown, I would have clicked the reverse. And then I assemble this axis again to this side face. Now, this will control how far to the inside I want my digit to be, right? So I'll put it 30 millimeters there. Okay, now look what I've achieved here. This can rotate, right? But you remember that if we change that selector variable, that digit 1 variable, it selects a different digit, but it's also at a different angle. And guys, here is the real magic. Finally, you will constrain this plane with this plane at an angle. Okay. What is that angle going to be? It's going to be 36. The included angle, again, you can bring this through a global variable if you want. Let's hit FX. And look, you see, we still have our global variables in here. Global variables is the only way to create a variable set that will show inside the Boolean environment. Okay. So if I put this digit 1, okay, it doesn't like it for some reason. Yes, because I forgot the multiplication operator, which is an asterisk. Okay, now look, this doesn't work, so we need to flip it. That's where we want that. Okay. So as soon as I flipped it, it lost the equation here. Okay, let me make that again. Yeah, so this should be plus 36. I was thinking about the directionality and whether this should be a plus or a minus, but it's very easy to see. We're going to flip the number and see if we get the number we wanted, then this plus is correct. If we get something else, it should be the minus. Okay, so there we go. Now we hit OK, and we have our number here. If we go now into our global parameters file and make this into a 1, okay, hit enter. We save and we update. Let's go back. So we got nothing here. Okay, that tells me that in here this little symbol should have been a minus. Okay, so the reason we're getting nothing here is very, very simple. Actually, I still think that this should have been a plus. It's just that the reason we're not getting anything there is because it seems this is not linked to the global parameters file. So let's go into our digit 1 part. And yeah, sure enough, it's not linked to the global parameters file. Okay. We need to change this into digit 1. Enter. There you go. It immediately snaps to 1 because in my global parameters, I've already switched this into a 1. If I open my test plate now, it should be fine. And it's upside down. So maybe this should be like this. Oh, guys, I'm going to leave this in because, this is something that you might encounter and you need to know how to fix it. So maybe this 180 thing is wrong after all. There you go. That's it. Okay, now let's play. Let's do some magic. We open it up again. Let's make this into an 8. Okay, I click somewhere else, I save and I update. 8. Okay, so I'll put in the other 3 digits and then I'll show you how that works. So let's test it and see what we did. Let's say that this is the number 812. Every time you change one of these digits, you need to click somewhere else, right? This is what gets put in. So for example, if I make this a 7, this hasn't changed yet, so I need to click somewhere else. Right now it's a 7, so I save this, I update my design. 712. So let's say that we hit the jackpot, all 7s across the board. Look, this hasn't updated, right? So I click somewhere else. Now I save, now I update. Jackpot. We have a serial number that can be changed through parameters, right? This is amazing, guys. This is, for me, this is like a magic trick, and it works, and it's great. And I hope you get to make something really, really interesting and impressive with it. So I hope you liked it, and I hope I see you in the next one.